dear.
James, what's the message? What's happening?
The hot water's fucked. Can't do the show without the fucking hot water. Can't have a coffee.
Hi everyone and welcome to Engineering. I'd like to first of all show you around the workshop and introduce you to the boys. First of all, we've got Brian Amos over here, who is our senior IT engineer, and maybe Brian can give us a rundown of what he's doing right at the moment.
Oh, I'm just putting those Queen tracks in Triple M's Maestro for the next hour, like you asked.
I'd like to introduce the newest member, or one of the newer members of engineering, which is Jason Cavacci, IT engineer. And over to Jason to tell us what he's up to at the moment.
Okay, at the moment I'm working on an on-air machine. There was a problem with it. It did fail while on air, so I've just rebuilt it.
Jason, there's smoke coming out the back there. I think we might just move along from there. Now I'd like to introduce the newest member to engineering, which is Andy Buick. He's on board as a OB and event coordinator.
Hi guys, I take care of the OBs, everything from getting there at 2 o'clock in the morning, setting all this stuff up and making it all happen basically.
Alright, now to introduce the final member of engineering, it's Daniel Chalmers, our senior technician.
Well, at the moment this is my major project, or our major project, and it is major. We've been required to relocate our main transmission site, which is located at Channel 10, Mount Cootha, about 50 metres across the road, which is a major project. Obviously we need to maintain on-air service while we're doing it. Basically what I'm doing at the moment is preparing 4 brand new equipment racks, which will house the new equipment that we're taking up to Channel 10, to the transmitter site. I'm pre-building them here just because it's easier, and once they've been built, we'll take them up to the transmitter site in one hit.
Now we'll proceed to the master control room area, which is where all PC network comes together and all on-air studio audio comes together. It's the engineering empire basically. And we'll start off by describing the function of the different rows of racks. For row A, I'll hand over to Brian and he'll go through the workings.
Well, the A-Racks is where our data and telephones all come and patch to each other. The start of these racks include our on-air mail servers, our internet firewalls, our streaming servers, DKS and all that sort of thing is in there. The next rack contains what we call the Cisco. It's where all your data points from all your computers come and patch in so you can access things on the network. On from that is all the data points on the floor come back to these racks here, including your data and your telephone. Everything comes back here and then it all patches into the Cisco or into the PAVX from here.
Brian, could you maybe actually demonstrate how simple it is to repatch a telephone around the building?
Sure. Pull that out of there and we'll patch it to somewhere else.
No worries, Brad. I'll get those reports to you straight away. Brad, hello?
Well, these 2 racks are totally dedicated to the operation of the newsroom. You can see we have several computers here. These operate the NewsBoss audio system for the news booth and the news workstations, preparation workstations. Also have a machine down here which operates the wires service. This wires service, very important machine. Basically everything dedicated to the operation of the newsroom is located in these 2 racks. This is the heart of the station. This is where our Maestro audio system, which contains all our music, commercials, and anything that's virtually played on air, is located in this rack. We have a RAID array system here, which is basically a whole lot of hard drives, a whole lot of redundant hard drives, which store the audio. We have redundancy on this system, obviously because it's so important. We have a main and a standby system. I can demonstrate that level of redundancy by turning off the main server, and the standby will automatically come online without any break in audio on air. I'll just demonstrate that for you right now.
Hello engineering, it's Beej. Man, I've lost all screens. Are we on air, off air, or what's going on?
Fantastic. I'm going to go and fix this.
I had no idea what's going on.
In the first lot you see here, we've got the production machines, they're Maestro and internet machines. In the second lot you've got the transfer machines, including their different sources that they get from, such as Sky and Dart. The next row of machines are some of our actual servers. So like we've got down the bottom there, we've got the backup server, which stores the backup tapes which are taken off site. Then we've got all the visual traffic servers and also the log merge server. The last row here is all our administration servers as well as our mail server. The administration server has a backup so that when the administration server falls over, it'll automatically switch over to the backup and no one will lose any data. I'll just show you that right now.
What's happened to all today's music?
Oh shit, what just happened to that prop? What's going on? I've worked all day on that.
Oh.
Has anyone else lost their stuff?
Oh, I don't fucking believe this.
And it's switched to the backup server without anyone losing any data.
Well, these are what we refer to as the analog racks. They're pretty much racks that you'll find in just about any radio station. Basically, where all the signals from the studios end up, we prepare them for transmission basically up to the transmitter site. We've got off-air receivers, so you can hear the radio through the building. Equipment so that we know we're off-air. Things for networking, transmitter remote control, ISDN facilities, and equipment to pre-process the signal before we send it to the transmitter site. And the patch bays too, so that we can patch things wherever we like in an emergency or for unusual situations. The rack in the middle contains our delay system for when we're in daylight savings, for network programs, monitoring here, so that we can hear just about anything in the building through this switch box. And the final rack is a mishmash of gear. This first slot here is satellite receivers for MCM programs and Sky Network. Master clock, link truck, flash log is here, some more patch bays for things that are common to both. The Intraplex, which is a fairly new thing where we receive network programs on now, and the in-house PA system. That's about it.
Another part of engineering is outside broadcast work, and to help make that happen we have a link vehicle.
Basically we have a whole lot of audio gear here, which is plugged into a transmitter, which is in turn plugged into a set of antennas on the roof, which are mounted on a pump-up mast.
So this is the antenna we use to get back to the studio. It's pretty important to get a direct line to Mount Cootha.
And of course, to get the best link back to Mount Cootha, we need to make sure the mast is all the way up, which is 9 metres, and from most positions around Brisbane, that's sufficient for a good link. What the hell's going on there? Oh, what's going on there? Hey Andy, is it a good line of sight?
Okay, now we've moved on to the comms room, what we call the comms room, which is basically where we keep the administration and on-air studio PABXs, which are these fellas. Also, all Telstra services come into the building in this rack here. They actually have a separate, it's their own property. And then finally, the last item of significance in here is actually the link transmitters, microwave transmitters. And these are how we get the program from the studio complex here up to Mount Cootha to our transmitter site. Okay. I think I might go up that ladder. Okay, hi guys. This is about the last part of our journey before we head to the transmitter site. And these two fellas here, the microwave dishes, B105 and Triple M, are the dishes to actually get the audio program to Mount Cootha. In actual fact, you've actually gotten lucky today because today is Engineering Chicken Day.
About an hour or so, I reckon.
Well, what's the weight of the chook there?
It's about
1.8.
1.8.
We've got about a metre. Yep, now it sounds good.
Go to the transmitter site.
Hi everyone and welcome to the transmitter site. Just give you a quick rundown of what we have up here. This is called a PI rack, program input rack, and we have the link receive. So before you saw the microwave dishes back at the station, it's actually received by these units, decoded from digital form, ready to be transmitted. Some technical things for basically making sure that we're within specification of transmission. Monitoring panel so we can listen to the stations. The Optimide 8400, which is the device that gives us a unique sound, does a lot of compression and graphic equalisation, that type of thing. Emergency CD player for those very, very few times that we're actually off air from the station. More processing. The link receive, so the link truck, that unit actually receives that signal and then via landline goes back to the stations. Over here we have the two main transmitters, A and B. Those try to provide a lot of backups, so if one fails it goes to the other, and at the moment both are running. I had the other one on earlier. I'll just turn this one off.
Members.
Then on a... Are we off air again? Oh, fuck! Fucking Steve Dane, shit!
Well, this is the Triple M side of things, the transmitter side. Very similar to the B105 link receiver unit, remote control unit, two Optimide processors which process the audio signal before we transmit it. Some monitoring equipment up here on this side, some modulation meters that allow us to look at how the FM signal is appearing on the receivers out in radio world, and just some switching equipment for switching different audio parts to air if we have to. That's remote controllable via the station, from the station end if we have to. Triple M's lucky because they actually have a brand new transmitter which was installed late last year, $150,000 worth. It's a Harris Z10 CD. It's different to the old transmitters that B105 and Triple M are using as a standby, in that it's made up of a whole lot of power amplifiers, which I'll show you at the moment. This one's actually on here at the moment. Each one of these power amplifiers produces 850 watts of power. There's a set in the back as well, all combined, and make up our base power of 5 kilowatts or 5,000 watts, which we transmit up the tower. B105 has one of these on order, and when we move over to the new area, as I was mentioning before, they'll get one of these which will be installed up there as well. For a standby transmitter, Triple M has this, very reliable NEC PTE. It's a tube transmitter like the B105 ones. Very reliable, but we only use that as a standby if this one actually has a fault. And just to give you an idea of how far we're moving all of this equipment, when we do the transmitter move I was talking about earlier back at the station, all of this, including the B105 side of things, has to move across the road here to the new TXA building, which I'll just quickly show you now. That's how far we're moving.
Come on in. We haven't actually got an exact plan at this stage, but this area here is where B105 and Triple M will end up living. As you can see, it's a very nice facility, and it's where Channel 10, 9 and 7 broadcast from.
That chicken's just about done still.
Oh, I should imagine so. Alright, well, hopefully everyone's enjoyed the trip through engineering land. Hope you've gotten something from it. And I know we certainly have. How's that looking there, Dan?
Oh, perfect. Look at that.
Beautiful. Let's have a look in there.
Perfect. Oh, it's done. Wonderful.
Beautiful. Alright, let's get that down to the boys.